This is part 2 of widening and narrowing in TypeScript. This is narrowing. It's based on this wiki page here if you want to read instead of watch a video. So narrowing. Narrowing has a number of different variants. And unlike the widening from part 1, narrowing is an external concept, which I'm sort of using to mean it's a thing that you need to understand to use the language. Whereas widening ideally stays inside the language. You don't have to think about it unless you're working with the implementation. All right, so the first kind of narrowing we're going to talk about is union narrowing. It's not actually called this in the compiler, but that's kind of a nice way to think about it. It's the most common kind of narrowing. You remove constituents from a union type. So say you have absolutely the most common kind of union type is thing or undefined. If you have thing or undefined, you might want to remove undefined from that so that you can use thing. So let's define some terms. You have declared type. That's the type of a declaration. Sometimes that's an explicit annotation like here, thing or undefined. Or it could be from an initializer. So if you have like var x equals 1, then x will have type number, and that's its declared type even though there's no type annotation. So a computed type then is the type at a particular location in your program, and that changes depending on the location. So if you've used the TypeScript API, you know that has get type at location. The reason you're required to provide a location is so that control flow can figure out where you are, and then it can narrow the type appropriately. So instead of following through here, let's look at the playground and we can actually see it live. Okay, so here we have this, again, we've got extra and it has type thing or undefined. That's the declared type right here, and that does not change. Then we have extra here. The control flow type, or the computed type, is still thing or undefined because we haven't done any checks to it. Here, the computed type is still thing or undefined because we're in the middle of the check, but inside the block from here to here, you can see that extra is now just thing. And in fact, we're free to use properties on things. So if you look at type thing, we have like kind 1, which has first property, and kind 2 has second property. So another interesting thing about this union narrowing is that it chains. So if you have a check on the property here, so extra.kind starts off as type 1 or 2, because it could be either one of these. And you have another check and assert that it's 1. You can see here that it's now just 1. And in fact, also you can access the first property, and second is not on there. Let's take a look. So you do extra dot, and has first in kind, but not second. Okay, so you can see that narrowed, so you can sort of narrow nested properties. You can also see that propagated sort of back up to the top level. So the check of extra.kind equals 1, because this is all one combined type. We also further narrowed kind 1 and kind 2 down to just kind 1. So it's sort of narrowing two things at once. It's narrowing the type of kind here, and it's also narrowing the type of extra. Let's see. So yeah, so you're down to 1 constituent here. Constituent is just a fancy name for member of a union type. All right, so that's union narrowing. And again, that's the most common kind. And the other 3 kinds are just actually kind of like 5, but they're all pretty similar and they all follow similar rules. They all can be used to do union narrowing as well. So let's talk about instance of narrowing, which is what you do with classes. So you can actually still do this with, you can still do union narrowing with this stuff. So say you have C or string, and that's a common thing in JavaScript where you pass, say, a config object or you pass a string, and then the string is like somehow processed some more to create the config object for you. You can use instance of here to find out if you have a C, and if you do, then C or S is known to be a C. In the else branch, then the computed type is now string. So this is still just union narrowing, where even though we're using instance of and not say type of C or S's string, we say CRS instance of C. The really interesting difference here is when you have subclasses. So you have subclass, class D extends C, it has another property, and then you pass a C in. So you start off knowing that this is a C, and then you can do an instance of check for the subtype, and now C or D inside the block, the computed type is D. And so that's a little different than union narrowing. Union narrowing takes a union and just makes it smaller. It throws out constituents. In this case, the computed type is actually different. So control flow narrowing is returning a different type than it was given to begin with. But it is related as a subtype. And if you make a mistake here, say you have class E that is not related to C, and you say C or E instance of E, then you get C and E as the type. And that's because, like, at runtime, you have proved that this thing is an instance of E. So it is definitely an E, but also you said it was a C in the type, so that it's probably right. I mean, you could be wrong, but you could be right. So the compiler just says, well, it's C and E, which could happen. It's a possibility. But in the else branch, it's still just C. And actually, when you do it correctly, in the else branch, it's still just C as well. Okay, so one similar kind of narrowing follows the same rules as subclass narrowing is type predicates. And this is basically implement your own instance of, but it's more flexible because you can put whatever you want to in the computation of whether the C that you provide it actually is a D. So you provide a C, then you say, when I return a Boolean that tells you whether C is a D or not, and then you write your code. And of course, this code is just bogus, but you can write whatever you want, and you can have any types here that as long as this type is a subtype of the type that you pass in. So it follows the same rules. If it is D, core 2, or sorry, C or E2, then it's a D, otherwise it's a C. And if you make a mistake, it follows the same rules. So that becomes a C and an E. Okay, so that's subclass narrowing and type predicates, which are pretty closely related. Once you understand the rules for subclass narrowing, then everything else kind of works the same way. So let's talk about in narrowing. Oh, I lied. In narrowing doesn't work the same way. It's actually sort of a third thing, and it's a bit strange. Now you can still use the in operator to do union narrowing. So if you have a C and an A, and you say if C and C are A, yeah, you have a C, otherwise you have an A. Okay, that still works the same way it would in union narrowing, and people do use it this way. But sometimes you'll have something that you starts off as a C, so you've got C+, and you just name an extra field that you know might be there. Say you've added it or something like that, or it's completely optional and doesn't show up in the types yet. You can't change C for some reason. So if you do that, you can say you have extra in C+, and then the type inside the block is C and record of extra unknown. Now, so that basically, record of extra unknown says you have a field named extra, and its type is unknown because you haven't said anything about what type it is yet. And inside the else block, then that's still just C. All right, so let's go back one. That takes us to unknown narrowing. But I'm going to go back to the playground for this one because it follows on very closely from in narrowing, because almost every time you use in narrowing to add something, to add a property, you're going to want to tell what property, tell what type the property is. So C plus extra, and I'll just say it's a string. Okay, so now extra's on there. It says it's unknown. But the odd thing is it's actually not. It's actually string. So you can see that's the case here. It's unknown. If you put it back in, it's a string. And in fact, you can do char hat and concat and all the stuff that you would be able to do with string. So that's just a quirk of the way that the type system displays its types. The C+ doesn't actually know that extra has its type unknown, but when you ask for the type of extra, it does in fact compute its computed type as string. And you might typically use this for something like with JSON, where you have a whole bunch of checks, and at the end you're able to say, oh yeah, JSON.extra type string. Although realistically, probably you'd actually have a type predicate here where you have something like function is payload, where JSON is unknown, and then you say JSON is some payload type, and then you put some code there. And then you just have at the very top of your function, if is payload JSON. And then the rest of your code is just gets to use that type. And of course, all your code that goes here would be pretty much whatever you would write here. It would just be nicely encapsulated away from the stuff, the rest of your code. And of course, that's using type predicates. And the type predicates can have unknown narrowing in them just fine. All right, so that's widening and narrowing in TypeScript. And yeah, thanks for watching.